Hey everybody, welcome to video 9-2B. We're going to work through these problems now about verifying whether figures are parallelograms or not. So here we're being given some information of values for variables, and our task is going to be, with the diagrams that we're given, to show that each quadrilateral is a parallelogram for the values that they give us. So let's talk through this first one, okay? In part A here, we're given that x equals 7 and y equals 4. So you can see that x has to do with sides BC over here and AD over here on the right, okay? So when we are thinking about substituting that x value of 7 in, we're going to get 7 plus 14, and we're going to get 21 for BC. Then, hopefully, we're going to substitute that same value 7 in for dA, and we get 3 times 7, and that is also 21. So what this has told us right here is that since these two values are the same, that means that BC is congruent to dA. So that's important first, and you can go ahead and, if you want, add those tick marks onto the diagram once you've proved it. Then step 2, we're going to use our y value, so we're going to plug that into our values for AB and CD's expressions. So AB is going to be 5 times 4, or 20, minus 4, and we get 16. And also CD, when we plug in 4 for y, is 2 times 4, which is 8, plus another 8 is also 16. So again, we have to say, what does this tell us right here? This tells us that those opposite sides, AB and CD, are congruent. And so we know that both pairs of opposite sides are congruent is one way of showing that parallelograms exist. So we have already verified this for example A. Okay, now we're going to move on to example B. And we're going to use the same idea with substituting variables in to see whether these are parallelograms in the diagram that we're given. So this time we have z equals 11 and we have w equals 4.5. So we have in step 1, we have the measure of angle F and angle H, these two opposite angles here that we want to find the values of. And so the measure of angle F is going to be 9 times the 11 that we were given, and then that is plus 19, and then that is going to give us 99, plus another 19, or 118. The measure of angle H is going to be plugged in as 11 times 11, and then that minus 3. So that's 121 minus 3, which does also give us 118. And so what we've just proved there is that since those degree measures are the same, that angle F is congruent to angle H. Step 2, we're going to verify the other variables now. We're going to put 4.5 in for E. I'm going to zoom in a little bit here so we can write this a little neater. Okay, so for the measure of angle E, we're going to get 12 times 4.5, and then that is going to be adding 8 to that for the measure of angle E, which is 54 plus 8, and we get 62 degrees there. Now we're going to plug that into 4.5 again into the opposite angle for E, which is, of course, H, so, which is, of course, G. So we're going to plug in, sorry for the fast zoom there, 14 this time, times our 4.5, and we're going to see whether that minus 1 gives us what we need. 14 times 4.5 is 63, minus 1 also gives us 62. So we're going to zoom back out And when we see that we have the same value again for that angle, remember that it is giving us a second pair of opposite angles that are congruent. So since the measure of angle F is the same as H, going in that first block there, and since the measure of angle E is the same as the measure of angle G, then we can prove that it's a parallelogram since both pairs of opposite angles are congruent. Okay, so we've just numerically verified whether a figure is a parallelogram or not. On this next page here, the next page 438 is where we are here. You're going to need to do the your turns for these two problems, 6 and 7. And again, I'll remind you to go back and click on the link for checking those answers so that you are ready to jump into the evaluate problems tomorrow in class. And you're going to do the same exact thing with substituting values and using the properties that you already know about parallelograms here. Okay, see you tomorrow.